Okay, so this is row 0. This is row 0. Row 1, row 2, row 3, 4, 5, 6, 7. So, do you see any correlation between the row and any number in those rows? So we've got this here is telling you the row number right there. So that's second number over. Okay, so what we have is we're going to talk about binomial expansion. I'll talk a little bit more about that in a moment. But what would 4 to the 0 be equal to?
1, 0, 0.
So I heard 0 and I heard 1. And then I heard 4. So one of those answers is right. So let's talk about, let's do it with the pattern. So what's 2 to the 3rd? 8. 2 squared? 4. 2 to the 1? 2. So now what are we doing when we're going up? So we're taking it and dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. What's 2 divided by 2? 1. So an exponent of 0 means you're going to get a 1. So that 4 to the 0 is 1. And what's 2 to the 0? We just say is also 1.
Okay. Wait, why wouldn't it be 2, 4, 4, 0?
So look at the pattern. If we take 8 divided by 2, it's 4. 4 divided by 2, it's 2. And 2 divided by 2 is 1.
No, I mean for like 4 exponent 0, like wouldn't that be 2 because 4?
No, because 2 to the 0 has to form that same pattern. We have to get a pattern with these numbers over here.
Okay.
So it just turns out that anything to the 0 then gives us a 1.
Okay.
So, and even if you look at doubling, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. If you look at it the other direction. Does that help, maybe? Okay, so we're going to use this triangle to do a binomial expansion. So remember on your homework, the last couple, I had you do like x plus 2 to the 4,
Yeah.
x plus 2 to the 3rd. That was a pain, wasn't it? Took a lot of time?
You did okay. It's fine.
Yeah. So there's a faster way to do it, and it's going to be using Pascal's triangle. I'll talk to you about it today. So I'm going to just put some of Pascal's triangle over here. 1, 1, 1, 2, 1. So if I take x plus 1 and square it, what I get is x squared plus 2x plus 1 squared. Do we notice anything with the coefficients here and Pascal's triangle? It's which row? Not the 3rd, but the second row. Because that first one is row 0. Yeah. Yeah. So remember, this is assumed to be a 1 in the front here. So we have a 1, 2, 1. Okay, here, and that's the second row. Otherwise, this is an exponent of 2. You think that's a coincidence?
Yeah.
No, it's not a coincidence. So x plus 1 to the 3rd. I'm going to look at that 3rd row over there. So where do my coefficients come from there? It comes from that 3rd row. So how now? So it comes from the 3rd row, the 1, 3, 3, 1, 1, 3, 3, 1. X plus 1 to the 3rd. what about the exponents on the x's? What's happening there? What's my pattern? What's my pattern with my exponents on the x's?
Huh? Ah, yes, you're going to get explained.
So what's happening with my exponents there? Two, one. What's happening with those exponents there? They're going down by one. So they're descending by one each time. These two are also 2, 1, and this could be like an x to the 0. That's right. This is like times x to the 0. We wouldn't put that there because it's simpler just to write a 1, but it could be the same thing. So if I did x plus 1 to the 4th, what I get is x to the 4th, 4x to the 3rd, 6x squared, 4x plus 1.
Wait, how do you know?
It's okay. You don't have to be able to do it yet. I'm still explaining it. Don't. So where do these numbers come from? So where do the coefficients come from? Yes, in which row? 4. And look, the exponent is a 4 there. So it comes from the 4th row. So this is where we can use that Pascal's triangle. Notice this is a binomial. 2 terms is a binomial. So it's the binomial expansion.
Can I go to the restroom?
So what's different? And then what do we say about the exponent on the x's? What's happening with the exponents on the x's? Somebody said it over here. Somebody else. I want you to recognize what's happening with the exponents on the x's. They're going down by 1. So x to the 4th, x to the 3rd, x squared x. And this one could be an x to the 0. This one. So what's different on the last one? Does this follow the pattern for the 4th row in Pascal's triangle?
No.
It doesn't. What's different? What do you know? What do you notice is different?
It's a 2 instead of 1.
That's right. This right here is a 2. So I'm going to show you how we find it. Okay. So on this next page, we are going to find x plus 2 to the 4th. So I am going to, this is an exponent of 4. So we are going to go to the 4th row in Pascal's triangle. So that is 1, 4, 6, 4, 1. Does that make sense? That 4th row is 1, 4, 6, 4, 1. So now we're going to take that coefficient, the first number, and put it right here. So this is a 1. And then I can cross that out if I want. And then this comes first in our binomial, so we're going to put our x first. And because it's an exponent of 4, we're going to put an exponent of 4 here. And then since this is a 2 here, we're going to make this multiplied by 2. And the exponent on the 2 is going to be a 0. That's a lot of steps.
You lost me.
Yeah, I don't understand it.
So I know I just introduced that for the first time for you. What's 2 to the 0? 1. So it doesn't change it, but you're going to see a pattern with that. So my next one, a 4, would be my coefficient next. And then what's going to be my exponent on my x? 3. And then my 2 is from here. What's going to be the exponent on the 2? 1. How'd you get that, Aiden? It goes up. So those numbers are going to go up. 0, 1, and so on. Yes?
So this might be a little, like, I have a question, but how come 2 is 0 is 1?
We just talked about it. Yeah, if you want to do some research later or stay after class, we can talk more about it, but I already talked about it. Okay, so on the next one, what's my coefficient?
6.
6. y is 6.
Y.
And then, what's the exponent on the x?
2.
2. And then exponent on the 2? 2. Questions on that?
I kind of get it now. I see what you're doing.
Okay, so
Wait,
somebody in this group here. What's my coefficient on the next one?
4.
Yes. And then x is to what exponent? This group again.
Isn't it just there because it's going down?
So,
Points.
anybody see that pattern? So 4, 3, 2, then what's the next? 1. So my exponent is a 1. And then what's the exponent on my 2? 3, because we have 0, 1, 2, and then this 3.
Oh. So how do you find
So
the
it's
first
all
one?
patterns.
How do you find the first ones? You dropped your mic.
I don't know what you mean by first numbers.
Like the first number in the
So this one here, so this number right here comes from Pascal's triangle.
where do you get those numbers from the triangle?
So it's the 4, because it's hold on a second, quiet please. He's
Oh, the
asking a
fourth
good
row.
question. Yeah, exponent of 4, so it comes from the 4th row.
Okay.
So now my last one is going to have an exponent of 1. What is the exponent on the x? Somebody in that group back there. 0. And what about on the 2? Yeah, good. 2 to the 4th. So now we're going to simplify it. Pay attention here. It's not hard. It's just a lot of little things. So 2 to the 0 we said is 1, right?
Yeah.
1 times 1 is 1. So this would just simplify to x to the 4th. So 2 to the 1 is 2 times 4 would give me 8 x to the 3rd. Because this is my simplified answer. This is what I want to get to. What's 2 squared? Yeah, so 6 times 4 would give me 24. So this is 24x squared. What's 2 to the 3rd? 8. So this is 4 times 8, which is 32x. 2 to the 4th is 16. And then nothing there because that x to the 0 is 1. Question.
Wait, I have a question.
Uh-huh.
So do the ones just like cancel out? They just don't matter.
So
Oh, never mind. I multiplied by themselves.
yeah, that's okay. Yes, Derek? Oh, sorry. Okay, so let's do one more and then I'm going to have you do one.
This is too much work.
It's a lot of steps. You have big 5 problems for your life. 5. That's it.
5 problems.
Oh my God, you're complaining about that? Maybe I add some more.
Some more.
So, okay, x plus 2 to the 5th. Which row of Pascal's triangle do I look at? 5th row. So I remember that the 4th is 1, 4, 6, 4, 1. So I'm going to use that to create the 5th row. I know it starts with 1. Yeah, 1, 5, 10, 10, 5, and 1. So remember, you can add the 2 above to get that. Okay, so what goes here in the first one? This group here. What's my coefficient in that first term? Yes. And then somebody besides Tristan, what's the exponent on the x? Somebody besides Tristan.
I've already done my due diligence.
Yes, Kobe, 5. Does that make sense?
Yeah.
5 comes from here. Yeah,
2.
you want to say what the exponent is on the 2? No, it's a 0. Yep.
No, I meant the next thing was 2. I didn't mean to.
Oh, okay. Yeah, I didn't see. You're right. So I'm going to show you something about those, adding those exponents in a moment. So what's my next coefficient? Somebody in this group here. What's my next coefficient? 5. What's the exponent on the x? Geronimo, do you know what the exponent is on the x?
6. 4.
You know the exponent on the x?
That's 4, right?
Yeah. And then Geronimo, can you tell me the exponent on the 2?
Yeah, look at you.
Yes, good. 1. Good. And so my next one, thank you those of you that are
Sonny
playing.
wants to do the next one.
Back here in this group, tell me what goes into the next plane.
Yeah, we should do this.
What's the coefficient and what are the exponents?
I guess we can finish.
X to the 3rd times 2 to the 2nd. Okay, next one, a group in the far back there. Tell me what numbers I put here, coefficient, etc. Good. Good. So then times 2 to the 0, 1, 2, 3. There you go. And then this group here. Go ahead and do the next one.
5 x to the 1st, or like 1, and then 2 to the 4th.
Okay, and then the last one, we're going to use the 1 times x to the 0, and then what's the exponent on the 2? 5. Good. Okay, so now we're going to simplify. 2 to the 0 is 1, so 1 times 1 is 1, so that's x to the 5th. 5 times 2? What's 5 times 2? 10, x to the 4th. Quiet, please. I'm not done talking. I'm almost done. So 2 squared is 4. So we want to take 10 times 4, which is 40, x to the 3rd. What's 2 to the 3rd? 8. So again, get to know that exponent on your calculator. This unit and some units after this, you need to know that exponent. So find where it is. Ask for some help if you need that. 10 times 8 would be 80, x squared. 2 to the 6th? Yeah, sorry, 2 to the 4th? 16. So this is 80x, and then what's 2 to the 5th? So it's 32, plus 32. Go ahead and do that last one, example 3. I want you to do example 3. Yes? Is there anybody that's still looking at this here? I want you to do on your own example 3. So you are doing this one. Please help each other. Some people get it right away. Some people just need a little bit of explanation. So if you can help, that'd be great. You're doing this one that's up here. Hi.
You just have to count.
So on the front, like on the front ones, they're always going to be 1, right? It's always going to be like x5 or x4 or whatever.
Third diagonal is always 1. That's what that means. Yeah.
Well, you know what 27 times 4 is?
So simplify it.
That's what you're. Yeah. Those results are 1, 2, 3. Those results are 1, 2, 3. And then row 4 is 1, 4, 6, 4, 1.
I know.
Find what 3 to the 4 is again.
Okay.
It's not moving forward.
Okay.
Just do calculator.
Okay.
Other than that, looks good.
Just like you said, remember the pattern actually.
You should be doing this example on your own.
No. No king food, buddy.
She's 12.
Yes.
Four times 3 is 12. This is right. This is right. Why do you have 12? That's we are huge.
Is there an answer to you?
if there's an open
Is there an
place,
answer sheet?
or if you want to move your chair around to sit with him, you can do that.
Is Casella?
I'm getting check number 3 before you go.